Okay, we are recording. Are there any questions? That includes you guys online. Volume all the way up. So we did last time. Are there any questions at all? Okay, we did 1.7 last time, I believe, and I didn't put up the homework for it. I just did it today, so I'm going to give you a week from today to finish it. So you can ask questions next time about that one. Yeah. Oh, yeah. Come on in.
Look, I don't get my hands. So can I come in on Wednesday?
Yeah. Is that for tutoring?
Yeah.
Okay, I'm gonna give you handouts today.
All right, thank you.
Thank you. All right, then what are we doing today? 1.1. Where's 1.7? Yeah, I think we did all that. Yeah. Okay. All right, I'll move on then. All right, then we'll go ahead and start 3.1, solving linear equations. That sounds, you guys all know what that is? When somebody comes in and out of the WebEx meeting. I'm gonna hand out some tutoring information. I put it on online too in Blackboard. They were available practically every day for your use, and you don't have to come in. I think you do it online too if you want to. All right, well, let me go ahead and start an example here. And see how well you know this stuff. Let's write this phrase. This class is going to involve mostly equation solving. What's so special about an equation? Can you tell me the one thing that makes it an equation? Equal sign. The equal sign. If it doesn't have an equal sign, it's not an equation. In fact, did you know that equal sign provides just the verb you need to make that equation a sentence? That, I mean, grammatically, it is correctly a sentence. But we're not interested in all that stuff. What I give you is something like this because I intend for you to figure out what the value of x is. X is an unknown quantity right now until we do something to figure it out. I've started off really easy so that you can probably look at it and go, the answer is this. Fine. What is the answer? Real quick. When you were in school, you're in school right now. You were in elementary school. Probably had problems like this on flashcards. Didn't you? You ever see those things? And so you had to fill in the blank. Now, what you were probably doing in your mind is you're going 8, 9, 10. The answer is 2. We're going to do things a little bit differently. And we're going to find out the answer by taking the equation that we have and doing our order of operations in reverse to go back and find out what x was. So what I do is I take this equation, and so long as you do practically the same, as long as you do the same thing to both sides of the equation, the equation still stands. What I did is I decided to subtract the number 8 from both sides of the equations. I did exactly the same thing on both sides. On the left-hand side, what happens to these 8s? 8 minus 8 is 0, isn't it? And then on the other side, it's just 2. So mathematically, I got what the value was instead of trying to figure it out in my head, because these will, as you imagine, become much harder. You guys with me? So we're going to do a few of these first, these one-step equations that will involve just exactly one step like I did to solve. What? I had x plus 8. What did I do? I subtracted 8. Why did I subtract? Because plus addition and subtraction are opposites, aren't they? So what I did here, try to get x all by itself on the left-hand side. I wanted to get rid of everything else. That means all I had to do was get rid of this 8. Since I had a plus 8, I knew that I needed to subtract it to undo it. But you got to do the same thing to the other side. Whatever you do, make sure you do the exact same thing to both sides. I will, that's not always 100% true about like, oh, come on, are you serious? Oh, I have to choose that. So whenever you see the word solve, it means solve for the unknown form. So let me do another one just like it. X plus 18 equals 40. Try this one now. Take a second and see if you can use exactly the same steps that I did. A problem like this, there's really only one way to do it. You get 24? So on the left-hand side, you would subtract 18, and you do the same thing on the right-hand side. On the right-hand side, I do 42 minus 18, and so I get x equals 24. Now, you might be asking, this is not usually the way I do these things. I usually write it in a much simpler, faster, more efficient format, and it looks like this. Usually, if you want to do the same thing to both sides, you can put your work underneath like that. This is common. People do this. Have you seen this? And so like this, then I add like this. So over here, if you look at x plus 18 minus 18, all I have left on that side is x. I usually try to line my equals up because it makes things easier to diagnose an issue later on. What's 42 minus 18? Yeah. Now, before I go on, there is one thing called checking. Do you know how to check your work to make sure that you got it right? How do you check your work? So to do a check, right, you plug your x back into the original equation. The original equation was this. Just believe me, these will get much harder today. So this is not, I don't want you to take these a little long.
Mr. Van Pelt,
Oh, yes, sir.
I can't see whatever you're writing.
Oh, I tried to share my screen.
Yeah. My bad.
That's my bad. Too much technology for me. Let's see. I need to share. So, share that, share. And there we go.
Thank you so much.
No problem. All right, well, luckily that was the easier ones. Make sure you turn off your speaker or there's feedback. So, good on checking, good on the things that you do, and the way we write it is generally this. Most people do this. I will only usually do one step per line. Also, besides only doing one step per line, I line up the equals. I'm giving you this advice because I've been doing this for a while, as you can imagine, and I'm kind of aware of the best ways of doing this. It's interesting though, that when I write something on the board, when I come around and see what the students write, many times it looks completely different than what I just wrote. But I have to try to keep it in mind. Right, let's try another example. So they'll get progressively harder, of course. So they just say solve. And let's do this one here. We've got 39 equals x minus 27. $66. There's an additional benefit over here too. When you do something like this, I've seen many students just use it as an adding thing and then do stuff like this. Do you realize, or at least you understand this, doesn't matter what side the x appears on? No. As long as it's by itself, I know it's valid. You understand? That's all I need to get to is what it actually equals. So whether x appears on the left or right is irrelevant. Many students, though, always want the left to appear on the left. Fine, if you want to do that, I don't care. But you don't have to. Did you get negative 39? Negative 39. So this time you subtract 13. Notice how you're undoing. Solving an equation is undoing because you're trying to come back to x. You know that x had been added to 13. You're trying to figure out what it was before that. Negative 26 minus 13 is negative 39. We'll do more. These one-step ones are just to get you warmed up. So with each of these, if I had subtraction, I did addition to undo. If I had addition, I did subtraction undo. Same thing works for multiplication and division. If I multiply, I divide to undo. So
14.
Not quite. You forgot one last little bit. Not 14. Anybody else? Negative 14.
Yeah, it's negative.
So what was the one step here? Divide, division. So you were undoing that one thing, which was division. That's right, you're undoing the multiplication. So you use division to undo that. The way I usually write that is this. You okay with that notation? So then on the left-hand side, these threes cancel out, and you're left with just x equals positive or negative divided by positive is still a negative number. 42 divided by 3 is 14. Right. I heard a muffled answer.
You said what?
I said I heard a muffled answer. Anybody get it? Positive 4? Right, because when you divide by negative 8, you want to divide by the whole number, negative 8. Do the same thing over here. And you have the answer. Let me give one other problem here. What if I gave you negative 3.7 equals negative x? Here you should get 3.
Is it x equal 3.7?
Yeah, positive 3.7. What'd you do here to get x by itself? What did you do?
Divide both sides by -1.
You could divide both sides by -1. Or alternatively, you could multiply both sides by -1 and you get the same result. So those negatives cancel out. The other side becomes 3.7. You got it. Let's do. Here you should have gotten negative 65. Negative 65, because what you want to multiply by is negative 13. So I guess you could write something like this. I can't slide in, I don't have enough room. But usually I would, so I'll multiply the left by negative 13. And I'll multiply the right-hand side by negative 13. What happens to the negative 13s on the left-hand side? That cancels with the 13, but that negative also cancels away, doesn't it? So all I'm left with on the left-hand side is X, and on the right-hand side, I get negative 65. Okay. What about something like this? Do I think I got it yet?
Equal 32?
Nope. Nope. 72 it is. There's a multitude of ways of doing it. This is where it starts to get hard. I have more than one way of doing this problem. Do it both ways that I know of. There may be even more. There are ways. Here is way number one. What I do is, you notice you got the 2/3 on the left-hand side. I am going to take and multiply the left-hand side by 3/2. Instead of having a 48, it's probably easier to have 48/1. Now, look, I told you there's more than one way to erase, and you don't have to erase properly, because you might have done it right. You did get the right answer, didn't you? Well, I bet you did. Who said 72? Oh, okay, then you read it. Then, okay, then maybe the erase instead. But no, I'm gonna do it another way anyways, because what I'm getting at. Look what happens to the left-hand side. When you remember when you would simplify, wouldn't this 3 cancel with that one? And wouldn't this 2 cancel with that? What's left over there on the left-hand side? Just X. That is exactly what you want to be left over. On this side, I have to do a little simplifying, like this 2 goes into 48 24 times. And what is 3 times 24? 72. I don't like the looks of some of the people in the classroom, so you guys follow what I did, you understand that it's 72. I'm gonna do it in a second way that might be more desirable. But I don't think so. So we've got 2/3 X equals 40. All right, we'll start with our 2/3 X equals 48. The most natural thing that students want to do is this. Did you think about dividing by that 2/3? Did it? There's a number of snags here. This will cancel here and here, and you will get the X on this side. This side is a lot more complicated. Because, do you remember what happened when you divided by a fraction? How would you simplify these things? Do you remember what you would do with the bottom one? That is probably a no, am I correct? That 42. But wouldn't you actually multiply by 3/2? What do they call that? It's this way, but then when you turn it upside down and multiply. What do they call that? Do you remember you take the reciprocal and you divide by a fraction? No. Okay, maybe we need a point of review. But this other side over here, it's probably easier if you put it over one. And so, is it that why you're looking at me weird? Because that's two, shouldn't have been there, 248. No, but it was a 48. All right, two goes into that 48, 24 times. You end up with 24 times 3 is 72. The last couple of steps in both efforts were exactly the same, because this happened anyways, didn't it? Reciprocal to 3 half. So based on the looks you were giving me, I think we need to do some more of these types before I get to the more serious hard ones. And anybody think they got it? 45? Anybody else? 4D? 4D is what I got too. So what did you do to solve it? Tell me the step. You multiply by the reciprocal? All right, so you multiply both sides by 5 halves. But it's a little bit, you can do it in one step, so I'm gonna do it this way. Watch this, I'm gonna do, oh, I didn't know it was moving. Let's do this. I'm gonna multiply by 5 halves. And I'm gonna do the same thing over here. Now, if you're missing a 1 that you need to help you, you can put it over there and it seems easier to do. Now, on the right-hand side, the 5 cancels with the 5, and the 2 cancels with the 2, and all I have is x left alone after all is said and done. On the left-hand side, that 2 goes into 16 how many times? 8 times. 5 times 8. Any questions about that? Anybody care to volunteer? 132 is what I got as well. This time, what I would do to solve this, I would not just multiply by only the reciprocal. Also multiply by the negative. If I do negative 4/3. And then you might find it convenient to put that 99 over. Left side would be easy. All these things cancel out. On the right side, the negatives cancel. The only other thing I can do is this 3 will go into 99 33 times. Those negatives also cancel. And 33 times 4 is 132. Okay, so develop your own comfort zone on these kinds of things. All the problems that we solve will eventually come down to this kind of stuff. It should be one step. But the very last step or two will be stuff like this. Evaluate that. Just tell me what the answer is. Anybody? 31, easy enough. What did you do first? You did this first. And then that guy you did second, correct? He said this all came out to be 30. Now, watch as I remake the problem, but put an X where that 14 was. We know the answer. Is all I'm getting at. But look what we did first and look what we did second in the original problem. Now, to solve this, you go in reverse. You remember when you were in grade school, did they read fairy tales to you guys? Grimm's fairy tales, anyone? Well, did they read the one where the two kids go and look for the witch in the woods? I think they what's Hansel, yeah, Hansel and Gretel. All right, as they're walking through the woods, what do they leave behind so they can get back? Right. Breadcrumbs. Everybody knows this story. So without the breadcrumbs, they couldn't go back. So we're doing like that. We're going to use we know which way to go forward. We have to go in those steps, but reverse every step in the reverse direction. So what I did first, I multiplied first and then I added. Now what I'm going to do first is subtract. So I'm undoing number 2. You understand? What happens when I do that? These 3's will cancel. I'll have a 28 on the right, and on the left I will have 2x. Right? So I undid that part. Oops. I undid that part. Now what next part do I need to undo? Multiplication. How do you undo a multiplication? Division. X is equal to 14 is our final answer, and that's because then I went and attacked the multiplication part of it. You get the idea? This becomes natural after you do so many of them, but in the early stages, it's very cumbersome. So you are reversing the order of operations in these problems because you're going to try to go back and figure out what that letter is. Throughout, I just want you to be aware that this X value has exactly one possible, this X, the number that goes in there is just the one number 14. Your book and some other people might say that that X is a variable. It's a false statement. It's a variable. Changes values. That's not changing value. So the correct terminology is to call this an unknown quantity. But your textbook will violate that, just so you're aware. All right, so these are the two steps that is what we're doing. All the previous problems took exactly one step. Now these will take two steps. So let me just make one up and we'll go from there. So the same deal here. I want you to solve 4x plus 3 equals, let's see, 109. Let me take a couple days for me to get this. You get 26? Good. First thing was subtract 3. Divide by 4. Now, even though I'm not doing it, you are expected to check these things. Not required. All right, now the rest of them, I'm just going to grab a bunch from the textbook. Increase in complication as we go. So we'll start. And by the way, does it matter that I use the letter X, or could I can use any letter? You know, it doesn't really matter. It's still just an unknown quantity. So variety, for example, your textbook does have to use your. You guys get 4? So the first thing was to add 5 and then divide by 2. This is longer than I thought it would take for this thing. Anybody get an answer? 0 is the answer. That sort of shocks students when you get an answer of 0. What would you do first? Like subtract 22 from both sides. So you do get 0 over here, don't you? Now, what was the other thing that I do to clear these out? What do I multiply by? It's the reciprocal, so multiply by 3/2. I'll do the same thing over here. You don't need to do over 1. What's 0 times anything? These cancel. One odd reason or another, some students, when they encounter a problem like this, they'll put no solution. 0 is what? 0 is a number like any other number.
With the divided for some reason. Oh, wait, I'm not dividing.
Yeah, whatever. Just, I think what happens is that certain answers freak students out, and then they will stop doing the correct algebra and start inventing things. Yes, stick to the rules, and the answer will be okay. So just to let you know, 0 is a perfectly okay answer. It will happen sometimes. It's fine. I'm going to go ahead and get there and come back about 2. So for the rest of the class, we'll just do progressively more difficult equations. Everything you got? 7/6, 7/6. All right, first step, it's, not everybody it looks like is on board with me for this one. What's the first thing you did? Anybody, I don't care. Subtracted 5 from both sides. So we got -12 sevenths x equals 3. I think you know where this is gonna go, so why don't you just put the 100 right now? You know what's gonna happen, right? All right, what's next then?
two, right?
Unfortunately, I did several. It's not even two, it's negative two. I have no idea.
Wait, I'm just talking about that.
After this
Bring it up.
semester, I'm gonna go. See, 3 minus 5 is negative 2. This is gonna get worse as I go. You might as well just take me now. All right, let's get out of here. All right, now let's try that again. I should have put over 1 though.
Yeah.
Because you know what's gonna come, right? Now you multiply by the negative reciprocal of the other side. So I would multiply both sides by negative 7/12. Do it over here too. The left side, everything cancels. So you get rid of everything over there except the x. On the right side, the negatives certainly cancel out. The question, by the way, did not ask you to simplify. It didn't say that. So you could leave your answer as 14/12. That would be acceptable because you're not required to simplify. You're so used to simplifying, you probably do it every time. So with that in mind, and you know, just randomly, they'll ask you to simplify anyways. So you might as well just do it every time, I suppose. Maybe that was their whole plan. Negatives go away, and what do we have left? 7/6. So in case you hadn't thought about it, one of the complications I was talking about was throwing fractions into these things. Here is a much more complicated one. 1 equals 3/5 minus 2/3 Anybody want to volunteer? Nope, it's a fraction. The answer is a fraction. The answer is a fraction. Uh-huh. Well, let's step through it. Well, tell me what you did first, just anybody. What are you trying to do first? So what'd you do to get rid of it?
Both sides.
But there's no net, subtracted the 3/5 from both sides. Okay. Of course, now you're stuck figuring out 1 minus 3/5. Does anybody know that? Off the top. Just cancel away. It's 3/5 each. Two bits. There's total 5 bits. 1, right? Take away 3 of those bits. You're left. Okay, and now what would you do? How would you just get the K by itself? And what would that be? No, you leave the K alone. This way, on the left-hand side, the 2's cancel, and I have -3/5. On the right-hand side, the -3/2 cancels with the -2/3. That's one method. I'm gonna do it a second way. This is one method, a second way. I'm gonna do a second way that I don't expect any of you to know, so I'm gonna just show you it. What you do is you look at the fractions in this problem. If you look at the denominators, I have a 3 and a 5. Can you tell me, based on your prior knowledge to this class, what is the LCD of all the fractions that occur in that equation? What is the lowest common denominator of all fractions that occur there? 15. Watch what I'm gonna do. I'm going to take this equation and I'm going to multiply the left-hand side by 15 and the right-hand side by 15. Now, as I multiply it through, I've got 15 on the left. On the right, I've got my 3/5. I'm going to use the distributive property to get the times 15. I'll put a 15/1 minus 2/3 times 15/1. What happens on the right-hand side? How many times does 5 go into 15? Get a 9 in that spot, you agree. I'll have left 3 times 3. Over here, 3 will go into the 15 5 times. What will I have left on this side? I mean, up that. Okay, there.
Say so, man.
Anything else not canceled? Looking at this piece here.
Right.
One I'm examining right now. That's what I'm looking So you're saying all that's left is negative 2k?
Times 5.
It's 5. So negative 10k. Notice the problem now. What is missing now? Fractions. Multiplying by the reciprocal, you wipe out every fraction. Multiplied by the LCD, wipe out every fraction. Now, this is the question we have. This is a far easier problem to do, isn't it? If you're willing to do that, then you get rewarded with a simple problem. If not, you'd be stuck doing it the other way. So with this in mind, then I'll go and do my usual stuff. I'll subtract 9. Finish it off. What would you do next? Divide both sides by negative 10. Even though you're not required to simplify, most likely when you go to look up the answer in the back or whatever, it will almost certainly have a simplified version of the answer. And you can see exactly the same thing we got last time. So you choose the one you want to do. I'll tell you what, especially if they have a lot of fractions, you're probably not going to want to do it. Because one thing about the LCD is it clears out all the fractions. If you have multiple different kinds of fractions in a problem, you're going to have getting new LCDs every time you encounter a new fraction. So that way that I did before this one can be way worse than what I did. Let me see if I can find something to illustrate my point beautifully. Let's find something with a variety of fractions in it, and I'll show you what I'm talking about. Now, unfortunately, I've also thrown in a way more complicated type of problem at the same time. Probably what I should tell you that the general plan when you're solving equations, the very first step, the thing that you want to do is simplify both sides of the equation. Use your methods to simplify them to do a slightly easier problem. So if you look on the left-hand side, you notice that I have a 1/6 and then the 4/3 can be combined. So just like we did in our simplifying, the very first thing you ever want to do is simplify each side of the equation. Now, if I want to combine these two numbers, what LCD do I need for that? Yeah. What LCD should I use for these two fractions? What denominator will be 3? You don't want to make.
Oh, I'm sorry, 9. No, 12.
No. Anybody? What about 6? Can't I change the 1/6 into a 1/6 and the 4/3 into an 8/6? Similarly with the W's, I need these to both have the same denominator. So I'm going to rewrite the 1/2 W as 3/6 W plus 2/6 W. So I have a bunch of stuff I have to do before I even begin solving the equation. Now on the left, notice the 1/6 minus the 8/6 is negative 7/6. And of the W's, I have a 3/6 W plus a 2/6 W, that's 5/6 W. Now it's similar to what we just did. So now, like normal, I'll do this. I'll add 7/6 to both sides. I've seen at this stage, what I've seen students do here is sometimes they'll write this equals 3/6. This way they can combine 3/6 and 7/6 to give them 10/6. Almost finished. What would you do to finish this problem out? Reciprocal.
5/6.
So multiply both sides by 6/5. And on the left, all that's left after all is said and done is the letter W. On the right, we can do some simplifying. So like these 6's will go away. 5 will go into 10 twice, leaving us with just W as. I'm going to do the same problem in a second way, but I'm going to do it where I wipe out all the fractions first. So let me come up and lasso it. Where you at? There we go. Just copy. All right, there it is again. So I showed you the one way by working the fractions each and every way. The second way I did is to wipe out all the fractions at once. Look among all the fractions you see in the entire problem. Can you tell me what the LCD of all fractions is? Something that 2, 3, and 6 all go into. 6. Won't 6 work? If I multiply, it's better yet, look at this. If I multiply everything by 6, that 6 will cancel into it. 2 will cancel into a 6, won't it? 3 will cancel into a 6, correct? So if I multiply everything by 6, and this is the way I represent it, I do this. I'm going to multiply both sides of the equation by 6. So when I do that, I got to multiply 6 to each and every component inside of this equation. Distributed. But the way it works then, when I go 6 times 1/6, I have 6/1 times 1/6 plus 6/1 times 1/2W minus 6/1 times 4/3 plus 6/1 times 1/3 W 6/1 times 1/2. So this is the post distributed look. Now, typically, you'll probably show or do less steps than I do. I'm trying to show you probably for the first time. So you're probably, or almost certainly you want all the details. But look what happens when I simplify. Look at the first piece here. This 6 cancels into that 6, and what are you left with of that piece? 1. Look at the next piece. What will I have left of the second piece? 3 what?
3W.
3W. You're not getting rid of the W, are you? So the 2 and the 6 cancel, and I get a 3W. All right, let's look at the next one. what are we gonna have here? 8. Continuing on, what are we gonna have on the next piece? What'd you say for the next one? 3, 3? It's 3 W's. 3 goes into 6 twice, so we have 2 W's. And then over on this side, what do we have? 3. Look at that equation. 0. Now, as what I was talking about before, as far as simplifying both sides, this is what I mean. Combine your like terms and all that stuff before you do anything else. So don't actually solve the equation yet, just clean up the sides. So on the left-hand side, if I clean it up, what do I get when I combine my like terms and such? Like, for instance, what do I got for the numbers? I'll try that again. What does the left side clean up to be? Yeah, clean this up. Equal. -7 plus 5, it's exactly what we're -7. 5W is 3. Now, by this time, it's become an extremely simple equation. This is like the ones we were doing earlier today. So we can add 7 to both sides. And I'll get 5W equals 10. And then if I want to get W, I have to divide by 5. Or did we get that answer before? That's the one we got last time. I'm going to give you one just like it. any of you that might not be multiplying by 4, instead decide to work the fractions, did you end up there? That's all you decided to multiply. How to get the 3? Well, it's 1/4 plus 1/2. That's how you get 3/4. The other piece was 2, 3/2. So your 2 minus 3/2 is minus 3/2. That's the same as 4/2 minus 3/2. So if you don't want to multiply through and cancel all the fractions immediately, you could work it this way. If I'm going to go this way, what would be the next step? Subtract 1/2 from both sides. And 3/4 n. Now over here, I'm going to have to make this -2/4 to play nicely with this 11/4. That'll leave me, when I add the two of them together, 9/4. Now what? Multiply both sides by 4/3. Then leave a 3 on the right, and on the left will be just the letter. So if you're not willing to multiply through by the lowest common denominator, this is how you're going to have to work fractions the whole time. I'm going to redo this, but without that. Multiply through by 4. Second method is to notice that the LCD is 4. So make a note somewhere that the LCD is 4. That way you know why you're multiplying by this thing. And so you're going to distribute this among all 5 pieces. And if you do this, you'll get better at it as you go along. Like, for instance, a lot of students after a while can simply do this. Notice how it wiped out. All fractions are gone now. The problem now becomes an extremely simple problem, at least in relative to the version you had. Here, we'll take our n and the 2n and combine them to become 3n. 8 minus 6 is positive 2. I will subtract 2 from both sides of the equation. That will leave me with 3n equals 9. Divide by 3. And you get n is equal to 3. It's also a good way to, it's good idea to have more than one way to do a problem. That way on an exam, if you get done early, you can do it in a second way and feel pretty confident on your hand. Now, remember, one of the things I said in the beginning or earlier was that you want to simplify each side of the equation first. So what does that mean on the left? What are you going to do with those parentheses and all that stuff? Distribute them, that's right. That's what you would do if you simplified. So you're going to distribute. This way, on the left, I'm going to see a 4z minus 8. Then I'm going to see a 3z plus 24. That equals negative 12. Now I can go ahead and combine my like terms. I'll get 7z plus 16 will equal negative. We okay there? Are we good? We'll come next. Subtract, so now it makes it standard one. We'll subtract 16 first. Common mistakes that students make are right here. Some of them will put something like -4 or +4 when the correct answer is -28. Don't forget what they're supposed to be doing here. So you got to add those two numbers together. And then to finish it off, divide by 7. So we get z is -4. That is the letter A, the one with the stubby leg. The one with the long leg is a 9. The 10A minus 7, that part there, what's in front of that parenthesis? That's right, a -1 is in front of that parenthesis. Did you guys do that stuff? I'll pause there because this is another place where students have issues. Look at all the signs. I didn't know if I mentioned, one of the reasons that people don't like math is because it's always this attention to detail. Always got to be paying attention. And light, we're not used to that light. But if you look carefully, this should look reasonable, but over here, if you don't catch it, it might come, surprise you. Did you notice that +7? I multiplied this -1. -1 times 10A made it -10A, and -1 times -7 made it +7. Stop me if I say anything. You guys need to control this and the other people. Whatever you do. Well, what would you do next? What would be the next step? Find length. What's the phrase? Like terms. So I'll have a 38 on the right, on the left still. What would it look over on my right side? 8A, because the 18A minus the 10A gives us an 8A. So instead of moving things around, I'm doing this stuff here. That thing and that thing gives us an 8A. So that took care of the A's, and that next I'm going to be looking at the numbers. What do you get when you combine those two? Positive 34. What's next? Subtract 34 from both sides. And I'm ready to finish off the problem. That's the last step. Divide both sides by 8. You could probably leave it as 4/8, but I will simplify it to be 1/2. All right. When I didn't assign homework for 1.7, I forgot to, so I just assigned it today. I also put in homework for the. Let me do a week today, so you get to ask questions about it on Wednesday. I know that homework, that some of the problems I was going to do today, if I had time, are much harder than these. So if you come back here on Wednesday with no questions, I know you didn't. Understand? All right, let's see you on Wednesday. Let me Where are you at, WebEx? Oh, there we go.